Hey everyone, in this video I'll try and explain the random forest algorithm with a practical example in our language. For random forest, you will also require basic knowledge about the decision trees. You can refer to my other video on decision trees for that. Now what are random forests? The most simple way to define a random forest is that they are an ensemble of decision trees. Ensemble meaning a group. It's clear from the name itself, a forest and a tree. A forest is a set of large number of trees. Now where does this word random comes from? Random because the random forest algorithm takes random samples from the input data set to make these decision trees. Now, since we would be having multiple decision trees and we would require a single output for our random forest, we use a method called as voting. A majority vote from the output of the decision trees would be taken and given as the output for our random forest. This output would be considered as the best and the most optimum. Now, consider this dataset. In this dataset, we have 6 different shapes. All the points lying inside the shape, each shape represents the various samples which we will be taking to generate the decision trees. It can be noted that there are some points which lie inside multiple shapes. Random forest uses a technique called as sampling with replacement. It would take all the samples lying inside, in our case, all the samples lying inside a particular shape, irrespective of the fact that they had already occurred in a previous shape. Now, when we get a large data set, all the points in the sample will be considered, and also if a other sample gets these points, it would also contain those points, so then these points can get repeated in multiple number of samples. A point to note is that the default number of decision trees which the R program provides is 500, so 500 such samples would be taken. However, this value can be changed. Now imagine taking 500 samples on this dataset. It would cover a large possibility of the datasets. Now we'll discuss the strengths and weaknesses of the random forest. They are highly tunable. Now, as I said earlier, the default package provides us with 500 different trees, 500 decision trees. This value can also be changed. Also, the R package random forest provides us with the option to control the number of input parameters to be selected for generating these trees. Also, other many tunable functions are also provided by the random forest. They are suitable for large and missing dataset. Since a large number of samples will be generated, the noisy and some missing values can get excluded in some of the samples, and since it would be excluded, and the output from the majority and the vote of the majority outputs would be considered, these values won't affect the final output much, and hence their random forest is prone to noise, is immune to noise and missing data. Now, weaknesses. It cannot be interpreted. In my previous video on decision trees, I explained about interpreting a decision tree. Now, since random forest is a group of large number of decision trees, it becomes difficult for us to interpret these trees. It takes higher computation time. Now, when the dataset grows very large in terms of GBs, then the computation time increases exponentially. Now, I would explain the random forest algorithm in the R programming language. We will be using the random forest library provided by R. There are other libraries such as Caret, RPart for this algorithm. The dataset used would be iris. The iris dataset has 5 variables: sepal length, sepal width, petal length, petal width, and species. Also, there are 150 cases, meaning the rows. Now, when we run summary statistics on the iris dataset, we get this output. We can see that the first 4 inputs are numerical and the final input, species, is categorical. It comprises of 3 factors, each having 50 observations, named Setosa, Versicolor, and Virginica. Now, you can notice a function called as set.seed. This function helps in regenerating the same subsets of trees for the which we would be getting from the dataset. That means that we would be getting the same decision trees from the input. Now, since random forest takes random samples, it is possible that the subsets taken may vary on each training program. So that's the reason we provide a seed. This would give us the same set of trees and same set of samples. Now we would run the model over here. Now you can note that this is the format in which we train a model. The point indicates that except species, all other parameters would be taken as the input. Now there are 4 others. Now when we print the details of a model, we get this. Number of trees 500. It's a default. We didn't change anything, so it remained the same, 500. Now number of variables tried at each split, it's 2. As I said earlier, that the default number of input parameters can also be is the square root of the input samples which we'll be taking. Now here we had 4 samples, so the square root of this is 2. Therefore our model took 2 samples from the input parameters. However, a point to note is that this can be varied. Now we can see that the out of bag estimate error is 4.67. Now this is called a confusion matrix. The rows indicate the actual values and the columns indicate the predicted values. You can also note a error class is also being provided over here. It can be seen that actually in the final row 4 observations were Virginica, but in actual versicolor, but in actual they were Virginica, so our model predicted this wrong. A simple way to identify the correct prediction is to check the diagonal elements. The diagonal elements denote the correct predictions. Now when we retrain a model by changing the number of input parameters to 3, we get this output. A point to note here is that the class error over here is 0.06 and here it's 0.08. When we change the number of input parameters to 3, we get this output. Now the error has reduced a bit. Now similarly we can play around with this and we can generate a better output. Now when we go through the details of the random forest algorithm, you can see that there are a large number of parameters which can help in tuning the model. We can change how dense the forest has to be trained, what should be the final node size, minimum node size, etc. Therefore this is the reason that it is highly tunable, and because of this it gives a good output in most of the cases, and hence it is one of the best algorithm which you can consider using in various data science computations. Thank you.